Hello, welcome to the Great Outdoors. Today we're going to look at the learning intention. I will understand how heat, which is thermal energy, is transferred. And in order to show that we understand that, we should be able to define conduction, convection, and radiation, and explain the movement of particles that happen during conduction and convection, and be able to apply this by describing examples of where heat transfer takes place. Conduction is the transfer of heat energy in solids. Particles in solids are close together and they vibrate more when they heat up. So if we look at this picture, you see heat on the left of the rod, and the particles on the left are vibrating, moving side to side with a big arrow, compared to the cold particles away from the heat that are moving side to side but with a small arrow. So when heat is applied at one end of the rod, the particles move from side to side more vigorously, and then they bump into the particles next to them, transferring heat and making them vibrate too. And slowly, as they bump into each other, the heat is passed from one end to the other end. So they pass this energy as the particles nearby collide with them. Metals are actually the best conductors of heat energy because in addition to having particles, they also have free electrons that are able to move. So these free electrons can move and therefore they can travel further and faster and carry the heat energy away quicker. So let's have a look at this picture. We have a Bunsen burner warming up one end of a rod, a wire, and you can see that molecules in solid objects, they don't actually move themselves, so we don't have molecules moving from this end and travelling all the way to the end. That's not what happens. It is the vibrations that get more rapid from the hot end to the cold end. So heat conducts from warm to cold. Convection. Convection is the transfer of heat energy in liquids and gases. The particles near the heat source gain energy and move further apart because now they are not trapped in a lattice-like structure like they were in a solid. Particles in liquids and gases are free to move. And as these particles separate, the liquid or the gas becomes less dense and rises. So we get a convection current forming. New particles are then brought close to the heat source and the whole thing can start again. So let's have a look at this saucepan. We have a heat source at the bottom, and as the particles heat up, they actually space out, and as they space out, the liquid becomes less dense and rises. And that allows new cold liquid to replace that space, and these particles can now be heated, move faster, separate, become less dense and rise. At the top they are cooling, so they are less spread out, they come closer together, more dense, and that's why it sinks. Radiation is our third type of heat transfer. When there are no particles to carry heat energy, you can still transfer heat by waves of infrared radiation. So IR radiation. It's commonly called heat. And we see this all the time in nature because that is our heat source coming from the sun through infrared radiation. Because space is a vacuum, in other words, it has no particles in it. Matte black colour is the best absorber and emitter of radiation, and silver or shiny silver is the worst absorber and emitter of radiation. So Mr. Flamingo, did you learn lots about heat transfer today? Great. We'll see you next time.